Seven circular dowels of radius 1 centimeter are bound by a rubber band. How much shaded area lies within the rubber band that is not taken up by the dowels?
So first, to solve this question, we need to break up this figure into a more manageable figure. So here I have broken it up into 6 circular sectors and 6 rectangles and 6 equilateral triangles. This is done by making circular sectors from radii perpendicular to the tangents from the centers of each triangle, from centers of each the each circle, that is each of these 6 circles, and then there's center in the middle
Six outer
circle,
circles.
and I just connect all of them because this is actually a regular hexagon, so I just made it into 6 equilateral triangles. So the shaded area, which was this area, is done by taking the sum of these areas and then subtracting this red area, which is the area of the 7 dowels. So first of all, these are circular sectors, yes, but how are we sure that this will add up to one circle? It seems obvious, but actually it's not that very obvious. So when there are two sectors like this, it was actually it's presumed that this is collinear and vertical, and this must be also parallel. This is presumed that is true, so we can conclude that this is true, which means we can do a translation. Since these wait lang. So these are two circles. We can do a translation. Since the circles have identical radius, we can just superimpose them. Doing a translation, when moving this one up to that circle or both, we can just show that these sectors, since this is a part of a tangent, will meet seamlessly. We can do this with all of the other sectors and conclude that these two, it will look like this, and then the others, etc. We can show that these 6 sectors can add up into one circle. So let me just put that. So these are 6 sectors, and that just adds up to one circle. So that's just pi r squared. And since the radius is 1 centimeter, then that is just pi centimeter squared. Now these are the 6 rectangles that are formed by the radii, and these lines that are formed by connecting the centers of the outer circles. So this is 1 centimeter, and this is also 1 centimeter. So we can conclude that this is 2 centimeters. And of course, this is also just one radius, so that's just 1 centimeter. So I'm going to put that here. 6 times this certain rectangle that has 2 centimeter length and 1 centimeter width. So that's just 6 times 2 times 1 equals 12 centimeters squared. And this is the regular hexagon, but I split it into 6 equilateral triangles, because why not? It's easier. So the formula for there's a derivation for this, but anyway, the formula for the area of an equilateral triangle is equal to square root of 3 over 4 s squared. So I'm going to put that to 6 times this triangle is equal to something, so we're not sure yet. So anyway, in this figure we can show that this is 1 centimeter because the radius, and this is also 1 centimeter, and 1 centimeter, 1 centimeter, 1 centimeter. So all of these sides are 2 centimeters and it's also equilateral. So anyway, these are 2 centimeters and then it's equilateral, of course. So that is 6 times square root of 3 over 4 times 2, which is the side length squared. This will be cancelling, so that is 6 square root of 3 centimeters squared, and then we add all of these, and then I'm going to write in red for the, actually I don't know what this is. Oh, that's green. Okay, this is the red one. So for the circles, which are the dowels, so that's just 7
So we,
times circle.
the blue ones, if you add them all together, they will be the
Wait,
total area of
this area
that
within
is
the entire
within the
rubber bands.
rubber band.
And then we remove the dowels, which is 7 pi r squared. Actually, if you notice, pi centimeter squared. Okay. If you notice, there's actually one circle that was formed. So I could have just eliminated that. Anyway, so I can do it right now. And then I'm going to put plus plus. And then this one is minus. So the result of this is simply actually wait, no. I'm going to use white. That's invisible. So the result is this one's gone. So that is 12 plus 6 square root of 3 and then minus 6 pi quad centimeter squared. So that's the shaded area that is in this figure.
Yes.
Okay, so I'm going to remove this. So find the area of the shaded region of the quarter circle. So basically this blue area. So to make this easier, just remove that. Okay, to make this easier, I already added this. So this is definitely the radius of
Radius
the
of the
big quarter circle, and this is perpendicular. So there's a center somewhere there. So anyway, since I'm just going to put it here, since this is a line and then this is circle there. So since it is actually it's not really good, I didn't state it, but this circle is meant to be inscribed between this line and then this other line. So this is tangent to this point and this point. So because of a theorem, I don't have the proof right now, but the theorem states that this must be perpendicular and this also perpendicular. So what does that say? Must be, first of all, this must be collinear, of course. And then this also means that this is the radius and this is also radius. So this whole thing is 2 radius.
which is the diameter.
So here, if this is r prime, that is 2r prime. This is also 2r prime. Okay, so now we can construct hypotenuse. This is the 40 centimeter line, and then this is the 2r prime line. We can construct a line which will form the hypotenuse of the right triangle. So that is conveniently from this, which is presumed the center of the sector. This is a quarter circle, and this is the radius. So of course, any line from the center to any point on the quarter circle, its measure will be the radius. So of course, this is the radius itself. So what does it tell us? This 2r prime 40. This must be r. So we can establish a relationship between big R, between small r and 2r prime. Okay, so I've prepared these figures. So first, using the Pythagorean theorem, two r plus 40 equals r squared So, we can conclude that 1,600 is equal to r squared minus 4r prime squared. Oops. There's the line there. And also, the shaded area itself is composed of the quarter circle here, which is 1/4 pi r squared minus, they're going to put it respectively, minus this circle, which is a radius of r prime, so this is equal to the area. I'm going to copy this actually. And then this, if we multiply everything by 4, that would just be 4a is equal to pi r squared minus 4 pi r squared. So the eagle-eyed among us will see that this is just r squared minus 4r. So does this look familiar? This is this. This is what's inside the parentheses over here. So we can substitute that for pi equals 1,600. So therefore a is equal to 400 pi.
Unit.
Centimeter squared. There. Nice. So I
Thanks
hope you
for
learned
watching.
something. Thanks for watching.